Oh man, so now we're tackling midpoints, which are super exciting. And these midpoint kinds of problems are not in the coordinate plane. Once we hit the coordinate plane, they are slightly different, so be careful. So example 6 says, if A is the midpoint of CT, okay, so this is a point, so point A is the midpoint of segment CT. That little line thing up there without the arrows means segment, okay, and it says if CT, so remember without the line, we're talking about the measure of the actual segment. So if the measure or the length of segment CT equals 5x minus 2, and the length of CA is x plus 2, find the x, then find CA, AT, and CT. Okay, so we got a lot to solve for. So remember, once we find x, we might not necessarily be done, which in this problem, we're definitely not going to be done. Alright, and remember, if you don't have a picture to represent the problem, I highly recommend you draw one because it'll kind of help you to visualize what is going on. Okay, so in this one, we have a segment of some sort. Okay, so I'm going to draw a straight line first. Alright, we have a segment, which means we have a start and an end point, which this is segment C to the T. So I got a C and a T. And it says A is the midpoint. So about halfway, or exactly halfway, but I'm just approximating since it's not drawn to scale. Okay, the midpoint to the point in the very middle is A. So if you guys see, it spells C-A-T. I love when my segments spell things. So, especially when they spell cat. I mean, that makes it even better, right? Alright, so A is the midpoint of CT. Now, if we know that A is the midpoint, using the midpoint theorem, we know that these two segments are equal, and this also means that these two are congruent. So I'm going to mark these segments with congruent marks. Okay, so remember when we have segments, we use little tick marks to show they're congruent, and we have to use the same amount of tick marks for the ones that are congruent. Okay, it also says that, let's see here, it says that CT equals 5x minus 3. So C to the T, this whole thing right here, is 5x minus 2. The C to the T. Alright, it says CA is x plus 2. Alright, and using this information, we have to find x, CA, AT, and CT. So there's a lot of stuff we have to find. Guys, which there are several ways to solve this. I'm going to show you the way that I would solve it, but if you have a different way and get the same answer, then that is perfectly fine. Alright, so when we do this using one of our midpoint theorems, we know if I use this segment right here, CA, what do you have to do to CA to get to CT? If we know that this is the point halfway in the middle, okay, what can I do to this segment to eventually get to the big segment? Holy hot dog, you guys are so smart. If I double this segment, I should get the entire thing since my A is the halfway point. Okay, so using that information, I know that CT, the large segment, should equal 2 times this piece, the CA. Okay, if I double CA, bam, I should get CT because this is our halfway point. Okay, so now, when I do this, you guys, I always like to write my segment pieces first and then fill in the values for my segments. Okay, so now let's solve this thing. So my CT, I know that CT is 5x minus 2. So I'm going to fill in 5x minus 2 for my CT equals 2 times my CA, which I'm going to fill in right here. My CA is x plus 2. Alright, let's start solving for our x now. Alright, so first thing I'm going to do, this 2 is sitting outside of a parenthesis. And whenever we have something hanging out in front of a parenthesis, the way we solve is by distributing that thing. So I'm going to distribute first. Okay, so we get 5x minus 2 equals 2 times x is a 2x. And 2 times 2 gives me a 4. Alright, now that my x's are separated, the way we bring those bad boys together is by moving one to the other side. And I'm going to bring my 2x to the other side to keep this thing positive. And the way we bring positive 2x to the other side, the opposite of positive, is a negative. So I'm going to subtract that thing on both sides. 2x minus 2x cancels out and turns to 0. 5x minus 2x gives me a 3x. So we are currently left with 3x minus 2 equals 4. All right, now that my x is on one side, now it's on one side, I need to move everything to the other side. So I'm going to start by bringing this negative 2 to the other side. So the way I bring a negative to the other side is by adding that thing on both sides. Bam. So negative 2 plus 2 cancels and turns to 0. 4 plus 2 is 6. So now I have 3x equals 6. All right, so we're so close to solving for x. Okay, so this 3 is secretly multiplying to my x, so the way we move it to the other side is by dividing it on both sides. 3 divided by 3 cancels and turns to 1, and 6 divided by 3 is 2. So yay, we know our x is 2. Yay! But that is only one piece of the puzzle. We know x, we still need to find CA, AT, and CT. Okay, so I'm going to solve for CA and AT over here. So I'm going to draw this line to kind of separate that out. All right, so we know over here that CA is congruent to AT, which means that their measures are equal. Okay, so I know that CA is congruent. This is my congruent symbol. You draw an equal sign with a little tilde thing. CA is congruent to AT, segment AT, which that means that their lengths are equal. And the way we show that lengths are equal is by saying the length of CA, that means I don't include the line, equals the length of AT. Okay, so once I know CA, I will know AT. So why don't we solve for CA right now? And once I know CA, bam, I'll know AT. Okay, so my CA equals x plus 2. All right, so let's solve for CA. Okay, so that means I know what x is. I know x is 2. So all I got to do to solve for CA is replace my x with the 2, or substitute it in for x. Okay, so CA equals my x is going to transform into this 2 down here. So that's going to become a 2. And 2 plus 2 gives me a 4. So the length of CA is 4 units. Awesome, awesome. And since CA is congruent to AT, which means their lengths are equal, that also means that AT equals 4. Awesome, man. Awesome sauce, right? Awesome sauce. That's cool. All right, so this is 4 and this is 4. All right, now there's 2 ways I can solve for CT. So I'm going to solve for CT over here. All right, so CT. We know that CT equals 5x minus 2. All right, so one way to solve for this is by substituting in my x where it goes, which we know x is 2, so I can transform this x into a 2. Or if I want, I know that, let me do that first and then I'll talk about the other way. Okay, so CT equals my 5 times my x, which I know my x is a 2. So this x is going to transform into a 2 and then minus 2. So CT equals 5 times 2, which is 10, and 10 minus 2 is 8. So CT is 8. Holy hot dog. Guys, so that's one way you could solve for CT. Another way, we could use something called the segment addition postulate, which states an entire segment equals the 2 pieces inside of it added together. Or I could even use this formula up here. I could say CT equals 2 times CA. Okay, however you want to do it. So I'll show you both of those ways, I guess. Might as well, right? The more ways, the better. Okay, so I could say CT equals CA, this piece plus this piece. So CA plus AT, and solve. Or I could say CT equals, I could double either CA or AT, and also get the length of the whole thing because A is the midpoint, which means this is half the length of the entire segment. So I could also double CA. And look, you guys, we should get the same answer every single time. So let's see what happens, okay? So my CA, we know over here is 4, as well as my AT. So I can replace CA and AT with what they equal. So CT equals my CA is going to transform into the 4. My AT is also the 4, and 4 plus 4 gives me 8. So that's one way. Or I could have just doubled CA. So CT equals 2 times my CA, which is a 4. Bam! And 2 times 4 is 8. Because there's lots of ways to solve for the same thing. So as long as you're doing the right thing, I really don't care which way you use. Whatever way makes most sense to you, you need to do. Okay? But awesome. So we found x, which is 2, CA, which is 4, AT, which is also 4, and CT we found in 3 different ways and got 8 each time. Holy hot dog, right? That was pretty exciting, if I do say so myself. So, awesome job, you guys.